Welcome to Blue Pen Land. Okay, so two speakers are 4 meters apart. They're in phase at a strangely specific frequency. If I'm 1.45 meters from one speaker with 3.201 meters from the other, how many wavelengths difference is the distance? Is it constructive or destructive? Okay, so by the way, we're not going to use that 4 meters, but I'll talk about it here a little bit. Here's this and this. So I'll call that speaker A, and this is speaker B. And we're told that they're 4 meters apart. By the way, they have to be at least a half a wavelength apart. So let's figure out what the wavelength is here. Wavelength is going to be velocity over frequency, right? So it's going to be 343, which is what we use for this whole test. And then our frequency is 877.24. So this ends up being 343 divided by 877.24. That is 0.391 meters is our wavelength. Okay, and if these speakers aren't that far apart, if you can never get there's no place in the world where you can have a half wavelength difference, right? If they're closer than a half a wavelength apart from each other, but 4 meters is enough. Okay, 4 meters is enough that we can get anything, right? So we are 1.45 from one, and I'm trying to draw this, and 3.210 from the other, right? So the first thing we're going to do is we're going to find the difference in the distance, right? The difference in path length is 3.21 minus 1.45 is... that's 1.76, right? Then we're going to figure out how many wavelengths that is, right? So that's going to just be L divided by the wavelength. So how many of these wavelengths fit into this distance, right? So that's going to be 1.76 meters divided by 0.391 meters. And that ends up being 4.5 wavelengths difference. Okay, now if it's some integer 0.5, okay, then that's destructive, because you have, when they're half a wave off from each other, you have destructive. Having a hard time with that, right? Remember, a whole wave looks like this. Whoops, looks like this. Okay, this is the whole wave. If you're half a wavelength off, then this is coinciding with this from the other wave, and you get destructive interference. Now, it's not going to be totally silent, and the reason for that is that speaker A at that point is going to be louder because it's closer. B is going to be a little bit softer. So it's going to be relatively quiet, but it's not going to be totally silent. Okay? So destructive or quiet, yeah, all right.